Good day, students. Welcome to Mathgotserved.com. And this clip we're going to be going over section 4.3a of our virtual geometry text on triangle properties. We're going to be looking at how to solve problems involving the median of triangles. So the problem featured here as an example of the kind of problem we are going to be solving. So let's say you have this triangle here, ABC, and CE is a median. CF measures 12 units and CE 18 units. Find the length of segment FE. Don't forget we have 6 practice problems at the end of this tutorial that we'd like you to try out in order to demonstrate mastery of the contents of this presentation. To gain access to our entire geometry course, Algebra 1, 2, Pre-Calc and Calc, just take a look at the links in the description below or visit our website at Mathgotserved.com. Alright, so the first question we're going to be addressing is, what is the median of a triangle? So this is our website, Mathgotserved.com. We're going to scroll down to the geometry vocab collection. Alright, so in the geometry vocab collection segment, we're going to go to number 16, which is triangle medians and centroid. So what is a median? You notice the definition here. The median of a triangle is a segment from a vertex to the midpoint of the opposite side. So look at this triangle right here. Can you identify the 3 medians? Segment AF, CE, and BD are medians of triangle ABC. Why? Well, because they start from a vertex to the midpoint of the side that's opposite that vertex. Okay? And you notice the relationship as a result of this special property. Well, since the median is a bisector, that means it splits that side into 2 congruent halves. So let's look at segment BC, side BC of this triangle, for example. Since segment AF is a median, it bisects BC. So BF is equal to FC, and half of the entire length is equal to either BF or FC. So that's what we're going to be focusing on mainly in this presentation. And in the next part, we're going to be looking at the centroid. Centroid is an interesting property of a triangle that's generated with the 3 medians of a triangle. So as noted here, the centroid is a point where 3 medians intersect. An interesting thing about centroid is that when centroids intersect, they bisect themselves at a ratio 2 to 1. So the longer side of the median that goes through the centroid is 2/3 the entire median length, and then the shorter side is a third of the entire median length. So that's basically what the centroid does when divvying up the medians. So we're going to focus on that on the next installment of this tutorial. Alright, so let's take a look at some examples. So something to note concerning all the triangles that we're going to be looking at in the example problems and the practice problems you're going to be working on is that the segments that are presented basically are the medians of the triangles shown. Okay, so for question number 1, let's say we have triangle SRT, and then SL is the median. So let's say we want to find the measure of LR if LT is 6 units long. Okay, so let's go ahead and solve that. Now, what do we know if SL is a median? Well, if SL is a median, we know that this side that's opposite this vertex will be bisected, right? So these 2 sides will be of equal measure. Alright, so let's go ahead and write down a statement. Since segment SL, since SL is the median or is a median of triangle SRT, well, we know it has to bisect this side. So we know that LR is going to be equal to LT based on the definition of what a median is. Okay, we're told that LT is equal to 6 units long. So how can we find LR with this information? Well, LT and LR are the same measure, right? So we just plug in what LT is into this equation. It gives us the statement LR is equal to 6 units long. Ladies and gentlemen, that is the answer of question number 1. Hopefully that makes sense, right? So if LT is 6 units long and they're both congruent, this will be 6 units long also. Okay, let's take a look at problem number 2. So problem number 2, let's say we have triangle CDE and the segment EM represents a median. So if CD is equal to 20 units long, our task is to find MD. How long is MD? All right, so since EM is a median, since EM is a median, of triangle CDE. Okay, I forgot to write that in number 1. So SL is the median of triangle SRT. So since EM is the median of triangle CDE, then what equation can we write that relates what we're given, which is CD, the entire length, with what we're looking for, which is MD? So what kind of relationship do we have between the given and what we have to find? Well, the relationship is as follows. So since this is a bisector right here, okay, it just basically tells us that MD is going to be half of the entire length. Alrighty, so MD, one of the sides, one of the portions of this side is equal to 1/2 the entire length. That is what a median does. It cuts an entire length right down the center. Okay, so we know that CD is equal to 20 units long. So what we're going to do to find MD is plug that value into the equation, the relationship that we have right here. So MD is going to be 1/2 of 20. All right, so half of 20 is 10. So that is the measure of side MD. Okay, let's take a look at question number 3. So for question number 3, let's say we have triangle QRS and we have two medians shown, RV and SU. Okay, so let's assume that VQ, segment VQ, is 11 units long, and we are to find SQ. Okay, so VQ is 11 units long, and we are to figure out what's the entire length from here to here. All right, so what is that? Okay, so what we're going to do first of all is let's write down the relationship between the side that we're given and the side that we know. We need to find. So since which segment are we going to be considering here? RV. Since RV is a median of triangle QRS, what do we know is the relationship between this portion and the entire length? This portion right here, QV, or VQ, doesn't matter, is equal to 1/2 of the entire length SQ. Okay? All right, so now we're going to use what we know to find what we need. So what do we know? We know that VQ is 11 units long. All right, so let's write that down. VQ is 11 units long. So if we substitute the value of VQ into this equation here, we know that 11 is going to be 1/2 of SQ. So if you just use your number sense and think about it, half of what number is equal to 11? It's half of 22, right? But if we want to solve this algebraically, we'll just simply multiply both sides of this equation by 2. So multiply by 2 and multiply this by 2. Why? Well, 2 times 1/2, that divides out. And we have our answer, 22 is equal to SQ. Or you can just say SQ is 22 units long. Ladies and gentlemen, that is the answer to question number 3. Hopefully it makes sense, right? So if this side is 11 and this side is congruent to this side, this would be 11 also, and then you can just combine these two together, and then you figure out that this is 22 units long. All right, let's take a look at problem number 4. So problem number 4, let's say we have triangle UVW with 3 medians shown. Okay, so VH, UI, and WG. Now, if we have a situation where GU, so let's write that down. If GU is equal to 12x minus 1 and GV is equal to 11x, let's find x. Okay, so we're solving for x here. So let's populate the triangle with the given information. So GU is 12x minus 1 and GV is 11x. So we want to find x. Okay, so with this given triangle and the fact that these are medians, what relationship can we generate? All right, so let's see, we're looking for since GU and GV are under consideration, we're going to be looking at our median WG. Okay, so since WG is a median of triangle what? Triangle UVW. What equation can we state? Well, we know that this median bisects VU right down the center. So these two measures will be the same, right? So we know that GU is going to be equal to GV by definition of what a triangle median is. So what we're just going to do now is just substitute and solve. Okay, so we substitute, we're going to have 12x minus 1, that's a measure of GU, equals 11x, which is a measure of GV. Okay, so let's get x isolated. I need the variables on the left, so I'll subtract 11x from both sides, flexing our algebra muscles right now. And then I need the constant on the right side, so use the inverse operation, add 1 to both sides. When you combine the equation downwards, you are going to get x is equal to 1. Ladies and gentlemen, that is the solution to question number 4. All right, let's take a look at number 5. Question number 5. All right, so for question 5, let's say we have triangle GHI. Okay, and we have just one median, IT. So for this particular problem, number 5, let's say where we need to find x if HG is x minus 1 and TG is, let's put TG down here. What is TG? Let's say TG is 2x minus 11, okay? So TG is equal to 2x minus 11. So let's solve this. All right, so we're looking at HG and TG. So which median is under consideration? IT, right? So since IT is the median, that's the given information, is the median of triangle GHI. Okay, we know that this shorter side right here, TG, is basically going to be 1/2 as long as the entire thing, right? It's going to be half as long as HG because segment IT bisects HG. Okay, now let's substitute the information that we have. TG is 2x minus 11 and HG is x minus 1. All right, so let's go ahead and solve this equation. The goal here is to isolate x. So we need to simplify this equation. We have this fractional coefficient here. Let's get rid of that to make it look pretty. So we're going to multiply both sides of the equation by 2. Okay. So we multiply both equations by 2 on the left side. These 2 and 1/2 are gone. And then on the right side, and on the left side, we're going to distribute this 2. And then we get, what do we get? We get 4x minus 22 is equal to x minus 1. Now to get x by itself, we subtract x from both sides. I need the x on the left side, and then add 22. Add 22, add 22. Now let's simplify this. So we have 4x minus x is 3x, 22, and these two cancel out. And then negative 1 plus 22 is 21. Okay, so to finish this off, one more algebraic step, just simply divide both sides of the equation by 3. That's the inverse of multiplication, right? And then that gives us the answer, x is equal to 7. Ladies and gentlemen, that's the answer to problem number 5. All right, so we have one more example, and then we'll give you an opportunity to do some practice on your own, okay? Okay, so for question number 6, this one involves multiple steps. So let's say we have triangle SRT. Let's write that. SRT. And we have median SL. Okay, so let's say we are given the following information. If TR is equal to 2x minus 4 and LR is equal to 2x minus 5, find TR. Okay, so in this particular problem, we're looking for the side of TR where the given side measures are algebraic expressions. So what does this mean? Well, let's see, we're looking for TR. So what we're going to do first, what we have to do first is we have to find x, okay? And then when we're done finding x, we can then use that to find TR since TR is dependent on x. Okay, so let's write down the steps that we're going to be employing to solve this problem. Number 1, you need to find x. And then for step 2, use it to solve for, use it to find TR. Okay, since you notice TR is dependent on x. Okay, so part 1, let's do part 1. Well, let's find x. So what statement can we write involving this median right here, SL, and this side TR and LR? Well, let's see, since SL is the median, what conclusion can we come up with? We know that LR is going to be half as long as the entire length TR. Okay, so if we substitute, LR is going to be, what is LR? 2x minus 5. And that's half as long as the entire length, which is 2x minus 4. Alrighty, okay, nice. Now let's solve this for x algebraically. We need to get rid of that fractional coefficient just as we did in number 5. We just multiply both sides of the equation by 2, and that should take care of that fraction, make the problem look nice. All right, so on the left side, we're going to be distributing this 2 to 2x minus 5. Okay, when we carry out that distribution, we're going to have 4x minus 10 is equal to, and then on the right side is 1/2 and 2 cancel out, is equal to 2x minus 4. Okay, we need to get x isolated, so subtract 2x from both sides. That'll move the variables to the left and add 10 to both sides. Add 10, add 10. Combine downwards. What are we going to get? Combine downwards, we're going to get 4x minus 2x. That's 2x. The 10 minus 10 and plus 10 cancel out. This is gone. Negative 4 plus 10 is 6. So we're going to proceed to divide by 2 both sides. And then we get x equals 3. Ladies and gentlemen, are we done? Is this the answer to the problem? Nope. When you're solving problems like this, make sure you're answering the question. The question said to find TR, okay? So we need step 2. So to find TR, we're going to start with what TR is. We know that TR is equal to 2x minus 4. That's what was given originally. And then we just take the 3 and plug it in here, right? And then we use PEMDAS to finish it off. So we substitute 3 into x. Okay, so this 3 that we found in step 1, we plug it into this x value, x spot right there. We're going to have 2 times 3 minus 4. So let's PEMDAS this real quick. Multiply first before we add or subtract. 6 minus 4 is equal to 2, ladies and gentlemen. That's the answer to question number 6. Alrighty. So now it's your turn to do some practice problems. Alrighty, so now we have 6 practice problems that we'll like you to try out to demonstrate mastery of this standard. So go ahead and pause the video presentation and work on these 6 problems. When you're done, initiate the playback and we are going to show you what the correct answers are. Alrighty, welcome back. Hopefully you had a chance to try out the given problems. Let's go ahead and show you what the correct answers are. For problem number 1, CL is 6 units long. For number 2, TU is 8.9. For number 3, x is equal to 2. For number 4, x is equal to 8. For number 5, BP is equal to 12 units long. And for number 6, UV is equal to 4. Ladies and gentlemen, how well did you do in these practice problems? Let us know in the comment section below what you scored. And if you have any questions or clarifications on any of these or what we went over in the presentation, just let us know in the comment section and we'll be more than glad to assist you. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful or if you want to help support our channel, just give us a like or thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel. If you have any questions or comments, just put it in the comment section below. And don't forget to visit our website at mathgotserved.com for tons of support resources to help you master geometry. Thanks again for watching and have a wonderful day. Goodbye.